All right, hello. This is my first try at doing a flipped classroom, flipped lesson. We're going to try to do product and quotient rules. Forgive it if it's ugly. I know I'm ugly. Hopefully it'll be beneficial to you. Here we go. All right, so we learned last time about the power rule. Magical way to help making finding derivatives easier. All right, there's a lot of other rules, and we're going to discuss two of them today, the product and the quotient rules. Now, if you remember from last time, there was a little slide that talked about the extra derivative rules where if you add two functions together and you're trying to find the derivative, just take the derivative of each one of them. Okay. Same thing work with subtraction, and the same if you had a constant in front. Okay. So the question here before we learn the product rule is, hey, does that same thing work for products? Can I, to find the derivative of two things multiplied by each other, can I just take the derivative of the first, derivative of the second, and multiply them together? So let's try this out. Okay, this is a pretty easy problem. That's why we're kind of showing to see, hey, does this work out? I want to find the derivative of x squared times x to the fifth. So if we want to do it, we're testing it out. Is this the same thing as the derivative of the first part, which is x squared, times the derivative of the second part, which is x to the fifth? Let's try it out. We know the power rules. So the derivative of x squared, we just take the 2, bring it down in front, and subtract the exponent by 1. So 2 minus 1 gives you 2 to the x, 2 times x to the first power. And we don't really need the first power. All right, so we do the other one. Derivative rule for x to the fifth. Again, it's a power rule. So you bring the 5 down, and you subtract 1 from the exponent, so it becomes 5x to the fourth. And if we multiply these out, multiply the coefficients, 2 times 5 is 10, x times x to the fourth, you add the exponents, 1 plus 4 gives you 10x to the fifth. Now the question, is that the actual correct answer? All right, well, let's try it a different way. Okay, x squared times x to the fifth, we know how to do that. All right, x squared to the x to the, times x to the fifth is simply, you said it, x to the seventh. You simply add the two exponents together. And now we use a power rule on this. We take the 7, bring it down, and we write the x, and we subtract 1 from the exponent, so it gives you 6. Well, are these two things the same? They're not. Okay, so this is just going to show that you can't just, for products, take the derivative of the first, take the derivative of the second, and then just multiply them together. Does not work. You have to have a special rule. All right, that's what this next slide is, and you'll see it in your notes. It's the product rule. The product rule says if I take the derivative of two different functions that are multiplied by each other, my answer is going to be the derivative of the first times the second left alone plus the first times the derivative of the second. So again, that is the derivative of two things multiplied by each other. It's the derivative of the first times the second left alone plus the first left alone times the derivative of the second. So there's really not much to do here. Well, say that. There's not much more to do here. So let's look at an example of this. All right, I want to find the first derivative of f of x is equal to 2x to the fourth minus 3x plus 5 times x squared minus the square root of x plus 2 over x. Now, if I really wanted to, well, I don't really want to. I could really distribute that through there and just do each individual part separately. Okay, and if that's easier, by all means do that. Your answer will just look different than mine, but it should be equivalent as long as you do everything correctly. All right, but using the product rule, we realize, hey, there's two parts to this. There's this first polynomial, which is not going to be too bad, and we got the second part, which is just a tad bit worse. All right, so using the product rule, well, I'm sorry, before I do that, we probably can rewrite some of this stuff over here. Okay, so instead of saying the square root of x, I'm probably going to rewrite that as x to the 1/2 power. And instead of writing 2 over x, I'm going to write that as 2 times x to the negative first power. Okay, just so the power rule is easy on us. So if we do the product rule says my derivative is the derivative of the first. So let's find the derivative of this thing. All right, so it was 2x to the fourth, so that becomes 8x to the third. I brought the 4 down, multiplied by the 2, subtracted the exponent by 1. Derivative of a minus 3x just turns into minus 3, because if you just have an x, the x goes away, that number, that coefficient stays there. And then the plus 5, well, it just goes to 0. So that's the derivative of the first. And then just rewrite the second one. X squared minus x to the 1/2 plus 2 times x to the negative first power. All right, and then I write plus, and then I do the second part of the product rule. Second part of the product rule is write the first part down, just as it was in the problem, 2x to the fourth minus 3x plus 5 times, and now we're going to take the derivative of the second function. So the derivative of x squared is 2x. The derivative of a minus x to the 1/2 turns into a minus 1 over 2 square roots of x. Okay? You can look up how to do that individual part separately. It's the power rule. I just went ahead and rewrote it so it looked nice, like a square root. All right, and then finally we do our last one. The negative 1 multiplies by the 2 to give me a minus 2. I subtract 1 from a negative 1, which gives me negative 2 as an exponent, which I could rewrite as x squared on bottom. All right, and that's it. Okay? If you can read this down here, or you can read it on your notes, a lot of the times when we're using the product rule, we got something ugly like this. Okay? Unless there's some obvious simplification, you can just totally leave your answer like that. Now, of course, on a multiple choice question, you might not see this answer. It might be simplified out. But honestly, the product rule is actually more powerful once we know some derivative rules for like sine and cosine and some exponential stuff. But this is kind of, hey, let's learn the product rule now. We'll apply it later. Okay? So feel free to rewind that one. Go back and look at it later. All right, we got one more rule. Oh, before we get to that, I'm sorry, I forgot about this. If we want to find, this example says, find an equation of the tangent line to this function. Okay? At x equals 0. This is the way it is in the book, so I know x equals 0 is way over here. That's weird. All right, but anyway, we know how to do this. We want to write the equation of the tangent line. That's that point slope form I showed you. Y is equal to m times x minus x1 plus y1. All right, we find our slope by finding the derivative and plugging in the 0. All right, our x1 is the 0, and the y1 is what happens when you plug in a 0 into the original function. So again, the slope is the derivative at that point. The x1 is that point, which in this case is 0, and our y1 is the actual function evaluated at 0. Once you got those three things, you plug it in. All right, so let's do the hard part first. The derivative. Okay, we have a polynomial times a polynomial. We could distribute that all the way out, but we're probably going to miss something. So let's use product rule. All right, so the derivative, using the product rule again, just kind of as a rehashing of it. You take the derivative of the first part, which would give you 4x cubed minus 6x plus 2. You leave the second part alone, x cubed minus 2x plus 3. Plus, leave the first part alone, x to the fourth minus 3x squared plus 2x. And then take the derivative of the second part, which in this case is 3x squared minus 2. Okay, and normally you would write this all on one line. I don't have enough space, so that's why I wrote it in two different lines here. All right, so this is the derivative function of this original function. So if I want to find the slope I need to take the derivative at 0. So that means I'm going to take this derivative function and plug a 0 in. All right, let's see what happens. I plug a 0 in. I get 0 for the first part, 0 for the second part, plus a 2. I get a 0 plus a 0 plus a 3, so 3. Plus, if I plug a 0 into this part, let me check that, make sure, yep, that just gives me 0. And a 0 for the second part there gives me a minus 2. I do my multiplication, that goes to 0, so my slope here, the derivative at 0, the slope at that instantaneous point 0 is 6. All right, so I can write that over here. That is my slope. All right, we also need to find what our y1 is. We can do that by just plugging in 0 to the original equation. All right, so I'll bring that down. To find the y value at 0, I plug 0 in, which what turns out here, I got 0 minus 0 plus 0, so I have 0 times 0 plus 0 plus 3, which is 3, and that actually turns out to be 0. Not very interesting on this one. So once I have that information, I can plug it into this formula. And so my equation of the tangent line turns into y is equal to my slope, which is 6, times x minus 0, because that's my x1, and my y1 is also 0. So plus 0, and that turns into y is equal to 6x. All right, and feel free, check it out, make sure I'm not lying to you. You can plug this into a calculator, the y equals, or plug it into Desmos calculator to see what it looks like. Plug this equation in, and you should see that at the point x0, 0, this is tangent to it. All right, that's our product rule. Because of time, I'm going to stop it right here, and you'll have to watch the next video for quotient rule. Sorry about that.